Hello, my name is Yehan Liu, and this is my Lab4 report about magnetic field of a bar magnet. So in this lab, we measure the magnetic field of a bar magnet using a smartphone magnetometer. We analyze how the field strength changes with distance and use the results to calculate the magnet's dipole moment. Then we build a closed-loop simulation to compare experimental data with theory. And about some equations evolved, the dipole magnetic field equation, derived from the Boyd-Sarved law, was used to model the field. We also examined how the field strength follows the power law relationship with distance. Also about the models, we used two approaches, an experimental model where we measure the field at different distance and angles, and also a computational model which simulated the dipole field in closed loop for comparison. And then let's see a preview of the results. From our data, we determined the power law exponent to be approximately negative 1.979 and the magnetic dipole moment to be 13.96. Then let's see the experimental model. First, about the experimental procedure, we first oriented the smartphone to minimize interference from Earth's magnetic field. Then we located the magnetometer chip and recorded field strengths along different distances on axis and at 45 degrees off axis. About the data on axis, the measured field values were recorded at multiple distances along the magnet's axis, showing an inverse power relationship with distance. And about the data of off-axis, we also measured the field at 45 degrees from the axis, confirming that the field weakens more rapidly in this direction, consistent with the dipole model. About the computational model, using closed loop, we implemented the theoretical dipole equation and plotted the magnetic field at the same measurement points. The simulation provided a direct comparison with experimental values. And of the results, both models confirmed an inverse relationship between field strength and distance. However, our experimental exponent was closer to -2 instead of -3, and the calculated dipole moment was higher than expected. Possible reasons included external interference and sensor alignment errors. Here are some possible errors. The first one is external magnetic fields or fields nearby electronics may have interfered with measurements. And the second one is inaccurate alignment of the phone or magnetometer could introduce errors in recorded distances. Then let's see the follow-up questions. About the first one, my answer is if the experiment was not aligned to compensate for magnetic north, Earth's magnetic field would interfere with the measurements. The recorded magnetic field values would include an additional unknown component, making it difficult to isolate the field from the bar magnet. This would lead to inaccurate calculations of the magnetic dipole moment and distance dependence. And my answer to the second question is, stacking two identical magnets end to end would double the magnetic dipole moment. Since the magnetic field of a dipole scales proportionally with mu, the measured field strength at any given distance would be approximately twice as large. However, the inverse cube dependence on distance would remain unchanged. Thank you.